I think I may have mentioned, but I'll mention it again just in case. These video recordings are limited to 10 minutes, so when I start getting close, I start panicking and cut things off. We will start back on page 6. I will go over the first couple of examples again that we covered on page 6 of section R.2. These were problems that we're going to solve using only positive exponents. So the first one where we have x with a -2 exponent, so we ask if anybody, if there are any bases with negative exponents, so that x on the bottom does. We take it and its exponent and move it to the opposite spot and then change only the sign of the exponent. So we have x to the second over 1. When it's over a 1, that 1 isn't necessary, so we can just write it as x squared. When you're doing your answers, it doesn't make any difference if it's x to the second over 1 or x to the second. Both answers are perfectly fine. Also, if you want to use the positive with it, it's perfectly fine as well. On problem number 2, we have a base with a negative exponent, so that exponent needs to go to the bottom to make it be a positive exponent. So we would write x to the -2 over a 1 and then take the x to the -2, take it down to the denominator and change the sign only of the exponent, so it becomes 1 over x to the second. When you don't have anything left on top, you want to make it a fraction, so you put a 1 up there as a placeholder. On problem number 3, we have the same situation except we have a number instead of a letter like we did in problem number 2. So the base is 5, its exponent is -3. We need to get rid of the negative exponents, so we take it to the bottom and it becomes 1 over 5 to the positive third, or you could write it as 1 over 5 just to the 3. On problems 4 and 5, again, we're looking for negative exponents. So this time, the 5 is on the bottom with a negative exponent. We need to take it up to the top. And again, we can write it as 5 to the +3 over 1, which is fine. Or we can make it 5 to the third. If we wanted to multiply it out, we could. 5 times 5 would be 25, and 25 times 5 would be 125. For the purposes of this class, you can leave those numbers expressed with an exponent, or you can multiply them out. Either way is okay. On problem number 5, we look at this as two separate problems. We look at the variable x. X has a negative exponent. Because of that, we take it to the bottom and becomes x to the second. We look at the y separately. It has a negative exponent also, so it's going to move to the opposite position too and become y to the second on top and x to the second on the bottom. The problems on page 7 are for you to work and try to come up with the right answer. The answers are actually on page 8, so after you've worked them, you can go back and take a look at the answers. I would like to take a look at number 3 first, though, because it's probably the hardest one on this paper. On problem number 3, we see a -4. -4 actually has an exponent. Its exponent is a +1. It is separate than the x. So we look at the base of 4 and we say, what's its exponent? Its exponent is a +1. It stays where it is. Then we look at the x to the -1. Its exponent is negative, so it needs to go to the bottom. So what I recommend doing is drawing your line first across and then putting the -4 on top, putting the x to the -1 on the bottom, and when you do that, its exponent becomes a positive. And then you look at the y separately. Its exponent is a +11. It stays where it is. So as you look at each one of these, if it has a positive exponent, it's going to move, it's going to stay where it is. If it has a negative exponent, it's going to move. So let me repeat that once again. If it has a positive exponent, it stays where it is. If it has a negative exponent, it needs to move to the opposite spot. If it doesn't have an exponent listed, like on problem number 1, its exponent is understood to be a 1, and you might want to go ahead and just place a 1 there. If when you move your exponents you don't have anything left on the top, then you're going to want to replace it by a 1. I'd like to take a look for a second at the answers that are on page 8, on the problems that you've just worked, especially like on problem number 5. Problem number 5, I have it expressed as 1 over 4 to the second, x to the third power, y to the third power. That answer is fine like that, Or the answer could be 1 over 16 x to the third y to the third power. Even though it says equal, the last one there doesn't necessarily mean that that's what I expect to see for your final answer. On that one, either two of those are perfectly acceptable. The other thing, if you remember from the first day of class, is that when we were talking about the commutative property of multiplication, 2 times 3 was the same as 3 times 2. So if you wanted to write this problem 1 over 16 y to the third power x to the third power, you could rearrange that. The numbers do need to be out in the front, but the letters are typically listed in alphabetical order, is how you'll find them listed in the textbook, and I think most of the time listed in any of my materials. But because of the commutative property of multiplication that says that y to the third x to the third is the same as x to the third times y to the third, either order would be perfectly fine on your homework or on a test. We're now going to look at some of the properties of exponents. That's on page 10 of your textbook. The first one is called the product rule, and it says that if x is any real number and m and n are integers, so that means they can be like -1, -2, -3, 0, 1, 2, or 3, then if we have that base of x to the power of m times x to the power of n, then the answer is going to be that same base, x, and we add the two exponents together. The rules that we're going to be studying here in the next few minutes are going to be ones that are going to make your life easier working with the product rules, or working with all of the rules that we're going to be talking about. You do not have to use them. They are really shortcuts for you to use. For example, if we have x to the third times x, we might want to put a 1 up behind that single x so that we understand it has an exponent. Then that problem would be x to the 3 plus 1, or x to the fourth power. On problem number 1, the example that we have listed here, x to the third is really 3x's multiplied. Remember from the first section of this chapter, first page of this chapter, that x to the third means x times x times x. X to the second means x times x, 2 of them. So if we count all the ones up that we have 5. So just by knowing what the definition of an exponent is, we could have worked this problem. However, the easier way to work this problem is by taking the 3 plus 2 and getting the 5. On example number 2, we have x times x to the fifth. This is really x to the first times x to the fifth. We add the 1 and 5 together and get x to the power of 6. It's also true with numbers, so be careful of the ones that use numbers on your practice test, and also in your homework, that 2 to the power of 3 really means 2 times 2 times 2. And 2 to the fifth really means that there are 5 2's that are multiplied. So if we count up all the 2's that are multiplied, we actually get 8 of them. The easier way to work this problem, though, would be having 2 as our base, and we add the exponent of 3 and 5 and get an 8. I know it's tempting to want to multiply those 2's there, but if you remember that, please excuse my dear Aunt Sally rules, that we have exponents and we have multiplication. Exponents are more important than multiplication. So in this problem, it is not multiplying 2 times 2, it's 2 to the third, whatever that is, which would actually be 8, times 2 to the fifth. Again, you can leave your answer as 2 to the power of 8 and not have to go ahead and calculate it out. On problem number 4, you see that there is one grouping of x plus y's. There are 5 groupings of this second group of x plus y's. We add the 1 plus 5 together and we get 6 of those total groupings. On page 10, we see another example, and that this rule is also true for negative exponents. So on the first grouping, we have -3, x to the fourth, y to the negative 3. There are actually 3 factors that are there. On the second grouping, we have 2, x to the -5th, and y to the -6. Again, there are 3 factors there. If we remember back to the rules for multiplication, the commutative and associative, we can rearrange those and group different things together. And that's what I've done over on the right-hand side. I've taken the -3 and the 2 and put them out front. I've grouped the 2 x terms together, and I've grouped the 2 y factors together. When I do that, I can take -3 times 2 and get -6. I take x to the fourth and x to the -5th. They have the same base, so I add their exponents together and get -1. I do the same thing with the y's, grouping The y to the minus 3 plus minus 6 gives me y to the minus 9, and then that gives me minus 6, x to the minus 1, y to the minus 9. That answer is perfectly fine for a homework answer if you want to do your homework that way. For the test and the practice test, what I would like to see your answer is expressed as it is below, with minus 6 over x to the first, y to the ninth.